All right, implicit differentiation with derivatives for Jeopardy. So I now have number one, so first times derivative of the second plus second times derivative of the first. And I plug in, so there's my 2 squared and my 3 times 1. My 1 and my 2 times 2. So there's a 4 on that side and a 12 on this side. And then I subtract the 4 over, divide by 12, gives me -1/2. And number 2 here, pretty simple, 12x squared, negative cosecant squared, that changes to a negative. And then the 2/3, this is x to the 2/3, or sorry, 3/2 power. So, sorry, what is it? 2/3 power, 2/3 power. So bring down the 2/3 and subtract 1 gives you -1/3. That is cube root in the denominator, so that's my D answer there. Number 3, I have a 6x squared, and then I have a product rule. So product rule is in there with that minus sign on the outside. This becomes a positive sign y dy dx, and then a 3 on the outside. So I have 2 dy dx's that I keep on the left-hand side. I take the 6x squared, I move it over. I take this 3y, move it over, and it's a negative, so I have to add 3y. And then I factor out the dy dx, and I divide it over for my final answer A. Number 4, I have a first times derivative of the second plus second times derivative of the first, and another product rule, first times derivative of the second plus second times derivative of the first, with a minus sign that gets distributed there. So I have 2 dy dx. Oh no, I'm not even going to do that. I'm just going to plug in -1 in for the x and 2 in for the y. So this becomes dy dx. This becomes a -4. This becomes 12, and this becomes -8. So I put the -12 on the right to make +12. And this 12 dy dx and 1 dy dx becomes 13 dy dx. And I divide it over to get my final answer. And number 5, last one here, 2x, negative sine dy dx. I plug in 2 for the x, pi right there. So 4, 2 times 2, and -1/2 gets divided over to get -8 is my final answer.